Good morning, mathematicians. We are looking at week 12, and it is Wednesday. This says write an expression to find how much of the square is shaded. So let's take a look at our rows as we've been doing for the last couple days. How many rows does the square have? Well, it has three rows. And how many of those rows have at least some shading? That would be one. So we know that our first factor is going to be 1/3. Now we're going to pivot and we're going to take a look at the columns. Well, how many columns does this particular shape have? This particular shape has 5 columns. And how many of those columns have some shading? Well, that would be 1. So our second factor in this expression is going to be 1/5. This is the answer right here. I have had two really good questions from students this week. One of those questions, when we're going over this week's summer review, is what part of this is the answer? So let's be clear that this is the actual answer, right? Looking at this model, helped us to find our factors, but this is the moment where we're actually seeing the answer. The other question, just to be clear, this is the same. So you could have this as your answer, but equally correct would be this to have as our answer. And we know that because remember that commutative property of multiplication, we can reverse our factors and we would get to the same answer. But the answer is not what we're after here. We're writing the expression. Okay, now let's take a look at volume. What an interesting shape. When we look at this shape, we have to break it into 3 prisms at least. You could do more than 3, but why give yourself extra work? Let's work smarter and not harder. Let's go ahead and take a look at prism A. Prism A is up here. And I want you to notice what I've done. Of course, we're going to use our volume formula, and it's very easy to see the length and the height. Those are labeled side by side, kind of perpendicularly. We see a length of 2, we see a height of 1. The harder dimension to see here is the width, but the width is this moment right here, isn't it? It's not labeled here, it's labeled all the way down here. So this is where we find our width. Our width is 4. So 2 times 4 times 1 is 8. So we do know that prism A has a volume of 8 cubic centimeters. Now let's pivot and let's take a look at prism B down here. And by the way, of course, you could divide this differently. If you divided it differently, let's check and see if you get to the same volume that we do. We can divide it differently, but we've all got to arrive at the same answer. Now, prism B, when we take a look at this, we can see very clearly right here that it has a height of 4, right? We said the width was 4 as well, and sure enough, that is actually labeled on prism B, but we're using it for our other prisms as well. So the last thing that we're looking for is the length. This is the length right here. Now that's not labeled. But if we come down here, we notice that the entire length is labeled as 3 centimeters. So where are we going to find how much is just this particular portion? Well, it's the difference between these two. If this whole length is 3 centimeters and this portion is 2 centimeters, the remaining part is 1 centimeter. So we do know that the length is 1. Now, take a look at what we're seeing here. We have a volume of 16, right? Because we have a width of 4, a height of 4, and a length of 1. So it is 16 centimeters cubed. Now let's take a look. Let's look at this small prism right here. We're going to call this prism C. It's very small. When I take a look at prism C, I do see that it has a width of 2 centimeters. I do see that it has a height of 2 centimeters. And what was the width? The width is the same for all of these. So it is 4. So this is going to be 2 times 4 times 2, which is the same as 8 times 2, which is 16. So we have 16 centimeters cubed. Where's the answer? The answer will be found when we add our 8 centimeters from prism A to our 16 centimeters cubed, of course, from prism B, and the 16 centimeters cubed from prism C. So we got 16 plus 16 plus 8. We add those together. We've got 16 plus 16 is 12, plus 8 is 20. So here's my 0, carry a 2. 2 plus 1 is 4. So we are looking at 40 centimeters cubed. That is what we are looking at for our prisms. Okay, now let's take a look at our next question. This does say to solve the following. When we take a look at this, we see that we have 4 times 5, 4 times 5. And let me go ahead and write this out so that we can make sure we're seeing exactly where we're getting these answers. This is part 1 here. 4 times 5 is going to give me 20, right? But then I have 4 times 1 fourth. Well, 4 times 1 fourth is going to be 4 fourths. 20 and 4 fourths is the same as 20 plus 1, right? Which would give us an answer of 21. So our answer for 1 is exactly. We are looking at question 2. 8 times 11 thirds. Remember, we will multiply our 8 times 11, which is going to give us 88 over 3, or 88 thirds. Now, you could report this as your answer. However, you could also do a little partial quotients or area model division and go ahead and figure out what this is as a mixed number. So let's go ahead and do that now. Now I know I could get 20 groups of 3, and that would use up 60 of this dividend, which would give me 28 left over. Now I see here, I can't do 10 groups of 3, but I could do 9 groups of 3, right? 9 times 3 would use what I have here. 9 times 3 is 27. So when I take a look at that, I would subtract and I have a difference of 1, right? So when I take a look here, I can't get another group of 3 from this, but I can go ahead and report this now as 29 and 1/3, right? So I'm going to go ahead and write that here as 29 and 1/3. You'll notice my video kind of jumped. I did the question 1 previously, and now I'm going to go back to that video so that we can jump into question 3. But you'll notice my answer coming up has a little error in it. So make sure that you're checking your answer with what we just did right here. Okay, one more question down here. We do have part 3 that we are looking at, and we have 7 and 21/100 times 7. Now, 7 times 7, of course, is 49, right? But now we can take the 7 and need to multiply it by the 21. Well, 7 times 1 is 7, and 7 times 2 is 14. So we have 147 hundredths, right? Now, when we take a look at that, we could go ahead and use some of this to add an additional one, right? So let's remember, we got this 41. We're going to put that to the front. And we're going to ask ourselves now, how many times can 100 go into 147? Well, it can go in one time. And there are 47 left over. So we're going to keep that as a proper fraction. Now, if I join this together, I do have an answer of 50 and 47 hundredths. So I'm going to go ahead and write that here, 50 and 47 over 100. Now take a look. That has been a lot of work in this teeny tiny box. So I do think, just so that later if I need to go back and analyze my thinking, I can kind of see here's the work from 1, here's the work from 2, and here's the work from 3. I'm going to go ahead and kind of separate those out. All right, let's take a look at this one. Find an expression, or write an expression rather, to find how much of the square is shaded. We've been doing this one a lot lately, so hopefully we're getting very confident in this. How many rows do we see? We see 3 rows. And how many of those rows have shading? 1 row has some shading. So here I see a factor of 1/3. Now I'm going to take a look at the columns. I'm looking at these vertical columns. I see 1, 2, 3, 4, 5. There are 5 columns. How many of those columns have some shading? Well, that would be 2. So here I see 2/5. So I am multiplying 1/3 by 2/5. And that is the answer for this question. Once again, just like we talked about above, we certainly could switch those factors and we'll still have the exact same expression. Both of those are correct. So this is kind of an either or situation. Our last question says, draw a picture of a rectangular building with a cuboid shape. Be sure to label its dimensions, and as a bonus challenge, we could create a design that combines two or more cuboids and make it look realistic. Well, I went ahead and got started over here. Okay, now part of what I want to do with this, unlike the last time we did this question last week, I believe, um, I had just one layer. So I really wanted to make something that has multiple layers here. That's why I went ahead and got started with this. So on this face, what will I draw? Let's go ahead and let's make here, let's make a length of 4, right? So I outlined this. You know what I'm going to do even better? I'm going to outline this in a different color so I can really see the difference for where these faces change. So I have given a length of 4. Now, this looks somewhat like a square. So I'm going to go ahead and also give a height of 4. Okay, I'm labeling my dimensions as I go. Now, if that is true on this face, doesn't that determine at least some of those markings that I need to make on my other faces? I'm going to use these lines here to continue them around the side. So if I have 4 layers here, I have to also have 4 layers here. Same thing is going to happen in this direction. If I am looking and seeing that I have 4 layers like stacks of bread, right, pieces of bread stacked up, then I can go ahead and continue those. The last thing that I need to do is decide exactly what the width will be. I'm going to change this up a little bit. I'm going to give it a width of 3. So now I'm going to go ahead and make sure I see 3 here. And sure enough, I do. So I have a length of 3, a height of 4, right? I'm going to go ahead and do the same thing here. This is 1, 2, 3. So I'm looking at 3 there as well. We have created the rectangular building with a cuboid shape. We have labeled its dimensions. If you would like to do that bonus, you could go ahead and draw another building attached to this one, which would be really fun. But I'm going to go ahead and stop it at this point. That finishes out our Wednesday